Today's my lecture topic is combustion in solid propellants. The propellants and the propellant components considered are double-base propellants based on nitrocellulose and nitroglycerin. Active binder based on inner polymer and a liquid nitrate ester. The propellants and the propellant components consist of inert binders such as polybutadiene, ammonium perchlorate, nitramines such as HMX and RDX. The features of combustion zone described are: in the condensed phase, the thickness of the temperature profile and of the decomposition zone, the kinetic of the decomposition, the energy released, the nature of the gas evolved, the surface temperature. In the gas phase, the type of flame structure, the possibility of staging, the energy released, the flame temperature. It is concluded that a fairly proper knowledge of the combustion of the various components and propellants has been acquired. Furthermore, based on this knowledge, first of all, modeling discussion can be achieved. The combustion of solid propellants include much work has been devoted in various countries in investigating the combustion mechanism of solid propellants. It is timely to bring together the information obtained by the authors and compare to that of literature on the combustion of the individual components as well as their combustion into propellants. The viewpoint adopted here is that of the understanding of the combustion behavior of propellants. Therefore, as much information as possible is presented about the fundamentals of the processes, whereas no attempt is made to establish a complete catalogue of practical results on various propellants with the different characteristics catalysts. Some space is taken up by chemical modeling. The aim is not so much to give the elements of mathematical description of the solid propellants. Double-base propellants. Double-base propellants are used in anti-tank rockets or missiles and in some tactical missiles. Their main advantage is that they produce a minimum amount of smoke, that is only from a small amount of additives. Second one is composite propellants based on ammonium perchlorate. Composite propellants without aluminum generate reduced smoke, HCl and H2O. Vapor will precipitate into droplets in the flume under given temperature and humidity conditions. They are used for various tactical missiles. With aluminum, they are widely used in missiles and space launchers. They produce alumina smoke, which in the case of space launchers could be considered in the future of undesirable. Composite propellants based on nitramines and an active binder are used more and more. Without aluminum, they are in the minimum smoke category and they replace double-base propellants. With aluminum, they reach the highest specific impulse and density and are used so far for upper stages of strategic missiles. The combustions of the components and then of the various propellants will be seen in the few combustion of double base propellants and active binders. It seems double base propellants are made in a number of ways. When they are rolled or extruded, the components are nitrocellulose and nitroglycerin, to which some stabilizers such as centralite and plastoid are added. When they are cast, a casting powder is swelled within the mold by a liquid mixture of nitroglycerin and paracetin. The grain thus obtained is then inhibited and used free standing in the motor. The propellant ingredients can also be mixed, cast cross-linked and grain base bounded. Depending on the relative amounts of nitrocellulose and nitroglycerin, the energetic level of the propellant can be increased, or in the usual terminology, its heat of explosion or calorimetry calorimetric value, that is, the heat evolved in a calorimetric bomb by combustion under an inert atmosphere. One can then talk about cool and hot compositions.